name is Hunter Costello, and today I'll be going over Lab 4 for EE120 Digital Design. And for the start of this lab, we have our memory address generator circuit. What this does for our microprocessor is that it allows us to access the next memory address from the RAM. So it'll start at address 0 for the microprocessor, and each time we clock, it'll get to the next instruction, so the next RAM address. After that, we have a 2-bit mux, nothing special. It allows us to select one input or the other. Simple simulation. Next, we have a 2-bit bus mux, which allows us to have two 2-bit inputs and choose which one we want. It's just a more complex version of what the last circuit was. And now we have our 2-bit reg. And what this does is the output Q and D, the input, both go to a 2-bit mux, in which case those two will be decided to go to output Q. So for example, we have D as 3. If we enable the mux to pass through B and raise the clock, Q becomes 3. Let's lower these. But say we want D to be 1, Q is now putting 3 to A, and D is putting 1 to B. If we raise the clock, though, nothing happens because what's getting passed right now is A. So say 2 now, we have to enable it and clock it. So it just holds the value for us until we decide to change it. Next is our controller, which holds the instructions for our microprocessor. The data bus tells the microcode which instructions to output. So we have these instructions right here, or the different way right here. And these are the instructions for what to do. So this will load the accumulator with the next RAM value. This adds to the accumulator with the next RAM value. This pauses the entire microprocessor to where the accumulator is. And this will check which ones are similar between the accumulator and the integer you want to check. So we see like data bus 0. You see this. It changes instructions. If we go to 3, it changes the same instructions. It just lets us choose which instruction we want. And this all comes together in our microprocessor. So the original program, but RAM and ROM would only put 3 into the accumulator and add 5, just doing arithmetic. And using modified RAM and ROM files, this one right here, and this one right here, I was able to create the AND function, which checks for bit places. So if you check the 2-bit places, it checks which ones are similar. And for that, I chose 3 to load into the accumulator, and we won't see it, or we see it right here. It's going to check the AND bitwise function of 3 and 5, which checks this to 1. And unfortunately, I wasn't able to get the other functions in here, but I do have the picture of the waveform. This is the waveform for the original RAM and ROM values. Even when I tried to go through it again, none of these changed, but if there was a section over here, this accum would change to 3 and then eventually change to 1. And that is it for Lab 4 for the microprocessor circuit.